Welcome to the session on trigonometric ratios, transforming trigonometric graphs. The objectives for this session are to sketch simple transformations of the graphs of sine, cosine, and tangent functions. The effect of transformations on trigonometric functions and polynomial functions is similar. Let's summarize some of these transformations. So consider a function f of x. Some of the transformations we can perform on this function are add a positive constant to x, take a positive constant from x, multiply x by a scalar, add a positive constant to f of x, take a positive constant from f of x, and multiply f of x by a scalar. Let's now take a look at the summary of these effects in pictures or graphs. So if we add a positive constant to x, the graph shifts left. An example here is of f of x plus 2. If we take a positive constant from x, the graph shifts right. Here we have f of x minus 2. If we multiply x by minus 1, f of x reflects in the y-axis. Now let's have a look at the effects of the transformations on f of x. If we add a positive constant to f of x, the graph shifts upwards. Here we have f of x plus 1. If we take a positive constant from f of x, the graph shifts down. Here we have f of x minus 1. And if we multiply f of x by minus 1, f of x reflects in the x-axis. Here's a summary of the transformations of the functions on your screen. Now let's have a go at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. Sketch the graph of y equals 2 sine x for x between 0 and 360 degrees. Here's a graph of y equals sine x. If we double this, we're stretching the graph in the y direction. Here's a vertical stretch of scale factor 2. This transformation hasn't actually been listed in the list of transformations on your screen. What about y equals minus tan x for x between minus 180 degrees and 180 degrees? Here it is. We've multiplied f of x by minus 1, and this is reflected in the x-axis. We're now going to have a go at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve example 2a first. On your screen is a graph of y equals sine x. You're required to sketch the graph of y equals sine x minus 90 degrees. In this situation, notice that we're taking a positive constant from x. So this is going to shift the graph to the right, as shown on your screen. The graph has shifted right by 90 degrees, or it's a shift of 90 degrees 0 as a vector. What about example 2b? Sketch the graph of y equals 0.5 plus sine x. This time we've added a positive constant to f of x, so the graph shifts up, as shown here. The graph is shifted up by 0.5, or we can say that as a vector, this is a shift of 0, 0.5. In example 2c, you're required to sketch the graph of y equals 1 minus sine x. This is a combination of two transformations. We're first required to multiply sine x by minus 1, and then we're required to add a positive constant. So let's have a look at both these transformations in stages. Here's the graph of y equals minus sine x. Next, we add 1. So first we reflect the graph in the x-axis, as shown here. And then we add 1, which shifts the graph upwards by 1, as shown on the graph at the bottom of your screen. We will now have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So for example 3a, we are required to describe the transformation that maps the curve with equation y equals cos x onto the curve with the equation y equals minus cos x. If we look at the list of transformations that we have on our screen, in this situation we've multiplied the function by minus 1. So this is going to reflect in the x-axis, as shown. What about example 3b? Describe the transformation that maps the curve with equation y equals cos x onto the curve with equation y equals 2 plus cos x. Clearly here we've added a positive constant to the function, so this is going to shift the graph upwards. So the function y equals 2 plus cos x has shifted up by 2. What about example 3c? We are required to describe the transformation that maps the curve with equation y equals cos x onto the curve with equation y equals cos x minus 45 degrees. So here we've taken a positive constant from x, so this is going to shift the graph to the right. So in our example, the function y equals cos x minus 45 degrees is a shift to the right by 45 degrees. Now take a look at example 4. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 4a. We are required to sketch the curve of y equals tan x plus 45 degrees for x in the interval 0 to 360 degrees. Here's a graph of tan x. Clearly, we have added a positive constant to x. So what happens to the graph? In our list of transformations, we have that adding a positive constant to x shifts the graph to the left. And therefore, our graph looks something like the one you can see on your screen now. The graph has shifted left by 45 degrees, or as a vector, this is a shift of minus 45 degrees, 0. Now let's have a go at example 4b. Sketch the graph of y equals tan minus x for x between minus 360 degrees and 360 degrees. Clearly here we've multiplied x by minus 1. So we're reflecting in the y-axis, as shown. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to sketch the graph of y equals sine 3x, where x is between 0 and 360 degrees. This is not in our list of transformations. Here's the graph of y equals sine x. So let's consider what's happening when we multiply x by 3. In effect, everything is happening to the function much sooner, so we're compressing the function. Or alternatively, this is a horizontal stretch of scale factor 1/3, as you can see in the diagram. This brings us to the end of this session. If you have understood its contents, you should be able to sketch simple transformations of the graphs of sine, cosine, and tangent functions. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.